Hey guys, good morning, good afternoon, wherever you are in your day. I wanted to put these on video so you could reference them as you prepared for your test. So the problems that you asked for through the blog, I just tallied up what they were, and these are the biggest hitters, so to say. So the biggest topic they came up was A not equal to 1. And there's also some talk of finish and solve. So I'm going to discuss that by setting this one equal to 0. Okay, and talk about when we're finished and how to solve things. So whenever I have A not equal to 1, I'm going to use a diamond. Okay. And my diamond is A times C. Okay, and in this case it is 6 times 3, which is 18. B is always in the bottom, regardless of what A looks like. So that's 11. Factors of 18 that give me 11, 9 and 2. Okay. I'm going to use these numbers to split that middle term. 6b squared plus 9b plus 2b plus 3 equals 0. I'm going to group now. And when I do that, I pull out a 3b, and I'm left with 2b plus 3. And I am left with a 1 here. I am going to finish the grouping process by writing my quantities. Okay. Now let me clarify here. If I was just asked to factor, then this would be my answer. I'd be all done right here. Okay, I've factored that, and how do I know that I'm done is I am down to some prime things here. Okay, as opposed to here where I am not down to primes right here. Okay, so when I'm all the way down to prime, then I can leave it alone. Alright, so that should address finish a little bit and solve, and I'll keep addressing those through the lecture. So the solve piece becomes, I'm going to set each one of these quantities equal to 0. 3b plus 1 is 0. 2b plus 3 equals 0. Because when I'm multiplying, if I have either one of the terms being 0, then I get 0. So now I'm just going to do the algebra to solve. Subtract 1 here, subtract 3 here, 3b is negative 1, 2b is negative 3, and b is negative 1/3, b is negative 3. Now that is solved. Okay, so that is solved. That there would have been factored. And that's pretty much what you're being asked to do on this. If you have a good hold on those two things and the difference, you should be in a pretty good spot. Okay. So that's the first thing you asked me to look at. The second thing you wanted me to look at is perfect square trinomials versus difference of squares. So I started with a couple examples to show you the difference. Perfect square trinomial, 3. Difference of squares, 2. 2 terms, 1, 2. Okay. Difference always has a negative there. Perfect square trinomials can have a positive or a negative there, and I'll talk more about that later. But really, perfect square trinomials, is this a perfect square, and is this a perfect square, and then is this double the perfect squares multiplied together? So x plus 5, x plus 5, okay, which is really x plus 5 squared. And you've asked me like what I prefer. I prefer this to see that. This is not wrong, so I really can't mark it wrong. Okay, cleaner Not wrong, so either way, I prefer this. Okay, does it work? FOIL, double distribute, whatever you want to call it. X squared plus 5x plus 5x plus 25. X squared plus 10x plus 25. That to me looks like the original. Okay. Difference of squares. Difference has to have a minus, and then there's only two of them, and they're both perfect squares. X minus 5, x plus 5. So again, if we talk about final answers, okay, if we're asked to factor, we would be good with this. We would be good with this, and it's preferred, and this would be acceptable. If we were asked to solve any one of these things, we would have to set each piece equal to 0. And solve from there using algebra. I'd take the square root here, and get x plus 5 equals 0. I would subtract 5, and I would get x is negative 5. I would add 5 here and subtract 5 here and get x is 5, x is negative 5. You can also write it as this, x is positive or negative 5. A little more on difference of squares. Excuse me, perfect square trinomials. I can't have a negative here. All it does is change the sign. So when I do this one, I've got x minus 4. Okay. And again, the check is x times negative 4 times 2. If I multiply those together, do I get that? And I do. So again, this would be the factored, squared. That would be factored. And then if I was asked to solve, I just set it equal to 0 and solve it. Use my algebra. That's the only difference. There's just an extra step or two. Okay, this one I chose. This is on the practice side, number 17 from the homework 2 nights ago. I chose because it's got a couple extra steps, and again, some of you, when am I finished? When am I done? Okay, so this to me looks like a trinomial. It looks like a perfect square, except if I take the square root of 9, I get 3, and 3 doubled is not going to get me 8. So I need to use a diamond. And I've got minus 9 and minus 8. And I'm pretty sure that that is minus 9 and 1. Okay. And when I do this, now I've got w squared minus 9 and w squared plus 1. I'm just splitting it because my a is 1 right there. Okay. Now I look at this. Is everything prime here? This to me looks prime. Okay. This does not. I've got some concerns with this being prime. That to me looks like difference of squares. I've got a perfect square, a minus, and perfect square. That's difference of squares. So w minus 3, w plus 3, and then I just bring this down. W squared plus 1. Now is everything prime here? And it is. So that would be factored. Okay, that would be factored. And then if I had to solve it, I would set each one of those equal to 0 and solve it. Alright, so that is that. Fractions. Some of you asked about fractions. So this is problem 23 from the practice the other night. Here's what this looks like. Here's how this goes down. So the big thing to remember when you take the square root of fractions is just taking the square root of the top, square root of the bottom. So if I was taking the square root of 16 over 81, square root of 16 over the square root of 81, which is 4 over 9. So same thing here. This to me looks like it might be a perfect square trinomial. So I'm going to try that. Okay. So I've got p minus square root of that is 3 over 5. I'm going to test it because I'm not sure, and it's a good habit to get into. So p times p is p squared. P times negative 3/5 is negative 3/5 p. Negative 3/5 times p is negative 3/5 p. And then multiply negative 3/5 and negative 3/5 is positive 9 over 25. That's looking pretty good. When I add those together, now I've got p squared minus 6 over 5p plus 9 over 25, which is what I had in the beginning. So I'm good here. Here is, this line is good. That is factored. And again, I'm going to write it the preferred way and solve it. So p minus 3 over 5 squared equals 0. Take the square root of each side. P minus 3 over 5. The square root of 0 is just 0. And then I'm just going to add 3/5 to each side. And I get p is solved. Factor. Okay. So, hope that helps. This will be on YouTube, so you can reference it whenever you're getting ready, and you have it. And we'll just keep working through and chipping away and getting better and growing for our assessment coming up. Thanks, guys.